Our LeetCode problem is longer substring without repeating characters. So we have a given string S. We have to find the length of our longest substring. That is without repeating characters. So we have to find a substring. So there's a difference between substring and subsequence. Substring means it has to be continuous. That is contiguous. It should come continuously. Subsequence means it could be like any way. Suppose substring is ABC, subsequence is AB, and then B over here. Maybe we take that. We can just write ABB. So that is not a substring. It's a subsequence. So we have to find the longest substring. That is, it should occur continuously without any repeating characters. So here ABCA, we can't take that ABCA because the we see that ABCA is repeating twice, so we can't take that. It shouldn't have any repeating characters. So can we take ABC? Yes, we can take that because it has all unique characters and has length as 3. So what is the maximum, that is the longest substring over here? That will be, the length will be 3. So we need to print the length as 3. Here everything is repeating, so the longest substring will obviously be just B. So B, the size is 1. Over here we can see the longest substring cannot be PWW because W is repeating. It can be PW, but its size is 2. But then it's not the longest substring. We can also make WKE, which is also unique. So we take WKE as our longest substring, and the size will be 3. Hence we print 3. So how can we code it into our problem? We can do this by having an approach like sliding window approach, it's called, and it'll be like we start from our left pointer and then there's a right. So we start with the L will be the start and R will be the end. So our sliding window such that um, so for initially L and R will be initialized to 0. So both L and R will be pointing to the 0th element, that is A over here. So suppose we take our string as A B C A B C D D. That will be the string that is actually given in our example, A B C A B C B B. So when we take this string and then we have traverse to the entire string first. So we start with 0 first. Okay, so left will be pointing to 0 and right will also be pointing to 0, and then what we're going to do is we are going to keep on incrementing r. So right will keep on moving forward while left will be present in that position, and depending on certain conditions left will also follow r. So both L and R will move together but then right only will move first and then L will follow right based on certain conditions. So we see that our length of this string is 7, right? Our length is 7 and sorry 7 8. Okay, it goes up to n minus 1. So length is 8 and our final index is 7. So the approach that we have to follow over here is, first we can just make something like first we'll enter into our array. So L will be 0, R will be 0. We'll take a variable called answer. So answer will store our final longest length. Okay, suppose 3 is the longest length, so answer will store 3 finally. So that will be, answer will also be initialized to 0 first. Then our first condition is count of s of r plus plus. So first we'll go into our while loop and then we will check if our right is less than the end of the array. That means our right should keep on moving till the end. Okay, so if it goes beyond the end, we cannot do anything about it. So we should constrain it to moving till the last index, that is 7. Okay, it shouldn't exceed 7. So while the loop iterates until right reaches the last element. So we will put a while loop for that. Then inside the while loop we can just write count of s of r plus plus. It means that we are going to for example right will be over here, right will be moved to over here, so it will point to 1. So then after that we are gonna, what is present in 1 index, it's b, so we will just increment our b to 1, right? Yes, so we will increment our b to 1, and then after that in the second sentence we will just statement, we will first check if our count is greater than 1. So we will store everything in our count array. So if b, right, we encountered b only once, so it'll just be 1. And suppose if it is greater than 1, then we will do something to remove it. And then finally we have to write our answer, that is answer will be initially firstly it will be 0, then our it will be equated to max of answer plus comma j minus I plus 1. So what it means is that on each iteration we have to choose the maximum value of answer and j minus I plus 1. So for example we can just take an example of this. Okay, so this is left and this is r. So for example, L and R are divided by some distance. So we have to find that length, right? So what can we do about it? So we see that R index is supposing it's present at 5 and L is present at 0. Okay, so index of L is 0 and index of R is 5. So we have to find the length between L and R. So how can we calculate the distance between L and R? R means we have to do R minus L plus 1. So R is 5, L is 0, so 5 minus 0 plus 1, so that will be 6. So the length of the distance, that is the window of L to R, the length of this window will be 6. How we can say that is 0, 1, 2, 3, 4, 5, 6. So we have to calculate 0 as well. We have to include that as well. So that will be 6. So that is how we calculate the length of the window. So that is why we are here. Here we are just calculating the max of answer and j minus I plus 1, which is the current length. Answer will be our previous length when we did for the previous iteration, but now our window has shortened or it has changed, right? Our L and R will be different for the next iteration. So this time it will calculate the length of the current one. That is new window. This one will be for the previous window. So this one is previous and this one is new window. So you have to just calculate answer will be maximum of the previous window and or the new window. So whichever window is the maximum, we'll just take that value as our answer, right? Next, the fourth. Okay, so these are the three main steps that you have to keep in mind while solving this. And this is the length calculation that you have to do finally. Then, yes, as I said, we have to remove it if our count is greater than 1. So we have encountered B once, right? So let's just keep on iterating and see. For C, okay, then C will also be incremented to 1. This is then A will be incremented to 1, right? Yes. So A will be 1, B will be 1, C will be 1. And then again for this time, when when our right points to this A, that is the index 3, you'll check that you'll see that A will increment again, and then A becomes 2, right? So A will become 2, and since A becomes 2, what happens here is I'll check for this condition fails, right? It's greater than, I mean, it actually obeys this condition. So count of this one will be greater than, is it greater than 1? Yes, 2 is greater than 1. So we have to do something to remove it. We don't want that A anymore because it's already repeating. Suppose we don't remove it, that means our A will be included and our answer will be wrong. We will have, we might have the longest substring, but we won't have the without the repeating characters. The characters will be repeating, so that will be wrong. So to include our condition as well, we will shorten our window. So that's what we're going to do. We're going to shorten our sliding window. So for that, we will just enter into a while loop. And here inside a while loop, we will do count of s of j. That is the pointing the right pointer. Or we can just write r. So s of r is greater than 1. So whenever this while loop will execute only when s of r is greater than 1. Okay. So if it becomes um, if it becomes 1 or if it becomes 1, then it doesn't enter into this loop. Then if it is greater than 1, that means b is equal to 2. We got b is equal to 2. So that time we will just reduce the count of b. So b will become 1, count minus minus. So b will become 1 and our left pointer will move increment and then will move one position to the right. Okay. So left pointer increments and our count decreases. So by doing this, we can just implement that removal condition. So decrease the count and increment the left pointers. That will be our approach. So let's just code it. Let's try to code it. So here we will just write int count. So there are 256 characters. So we'll just write 256 as our array. So we will store everything. We will just initialize to 0. So everything will have a 0 value here initially. Then our int I will be 0. Then int r will be 0, right pointer. Then both will be 0, then our answer will also be 0 initially, then we can change it. Then I will enter into a while loop. While loop will be going until s dot length of, beyond this it can't go, so we will just stop it after this. Inside this loop, what we are going to do is we are going to we are going to increment our frequency, right, of what? Of the element present at the right pointer, so we will just increment that. And after incrementing, we are going to check for very important condition, which is we will check for the count if it is greater than 1 or not. So right pointer, is it greater than 1? Suppose it is greater than 1. That means we're having duplicate elements. That means we're having non-unique elements. So we have to do something to remove those non-unique elements. We do not want any non-unique elements um, in our thing. So we will just plug the L minus minus, it will decrement it, and we will increment our L, that is the left pointer, and then we can come out with the while loop, and we can do this. We can calculate our answer value by taking our max of the previous answer from the previous window, and then our new length of our window. This is our new length, r minus n plus 1. And after that, we can just increment our r as well, because we have to go on, can't stop anywhere. And then after we have, so finally we have to return our answer. So everything is right over here. I'm going to run my code. Yes, so it has worked. So thank you for watching. This is one of the approaches that we can follow.